This is the second video for section 13-5 in accelerated geometry, where we're talking about solving rational equations and inequalities. And so we're going to start today with something you all love, a word problem. This says Natalie can finish a 500-piece puzzle in about 8 hours. When Natalie and Renzo work together, they can finish a 500-piece puzzle in about 4.5 hours. How long will it take Renzo to finish a 500-piece puzzle if he works by himself? You see questions like this all the time on the SAT and things, and people just get stumped by them completely. So today you're going to figure out how you can solve these. So let's talk about if they work alone. If Natalie works alone, then in 1 hour, she can get 1/8 of the puzzle done per hour, right? Because it takes her 8 hours to finish the puzzle. So we'll say 1/8 of the puzzle per hour. And so if Renzo was working alone, his rate would be 1/h, because we don't know how many hours it takes him to complete the puzzle. If we did know, if it was 10 hours, for example, then his rate would be 1/10, 1/10 of the puzzle per hour. Together, Natalie and Renzo together, we know that they can finish it in 4.5 hours. So their rate is 1 to 4.5. So they're putting together an entire puzzle, though, and they're working together to do that. So we would take Natalie's rate, which is 1/8, plus Renzo's rate, which is 1/h, should equal their combined rate, which is 1/4.5. And so this is your equation now, which is really not all that difficult to solve. And if you remember from this video, the first thing we would want to do is we would want to multiply through by a least common denominator in order to get rid of those fractions there. So your least common denominator, if you take 8 and multiply it by 4.5, you should get 36, and then of course the h. So our least common denominator is 36h. So when I take 36h and multiply it by the 1/8, that gives me 4.5h plus 1/h times 36h is 36, and 1/4.5 times 36h is 8h. So now, I mean, this is a middle school problem at this point. I would subtract the 4.5 over here with the 8, so that gives me 36 equals 3.5 times h. And then we take the 36 and divide it by 3.5, and we get 10.29 for h. So that's the total amount of time it would take Renzo to finish the puzzle. And so once you solve for h, you want to make sure to go back and read the problem and make sure that you actually answered what they were asking. The question was about how long will it take Renzo to finish a 500-piece puzzle if he works by himself. So you figured it out. It's going to take him 10.29 hours. And if you wanted to, you can convert the 0.29 into minutes. You could just take 0.29 and multiply it by 60, since there's 60 minutes in an hour, and it becomes 10 hours and 17 minutes it would take him to do a puzzle all by himself. Okay, so that's a recap of solving equations, but today, for the most part, we're going to be talking about rational inequalities. A rational inequality is an inequality that contains one or more rational expressions. So it's just like the equations from yesterday or from the last video, except rather than equal signs, we have inequality signs, like 1/x is less than or equal to 4, or 1/x plus 2 is greater than x plus 3 over x squared plus 4x minus 5. I don't know, I'm just making stuff up there. But those are what rational inequalities look like. And we're going to start by solving them by looking at graphs and tables. So you're going to want your graphing calculator out for this part. So for number 2, we're looking at x divided by x minus 6 is less than or equal to 3. So what you're going to do is whatever's on the left side of the inequality, that's going to be your y1. Whatever's on the right side of your inequality, that's going to be your y2. So go to your graphing calculator. I'm going to give mine a minute. My computer's being kind of funky today. And while we're waiting on mine, I want you to go to the y equals on your calculator and type x over x minus 6 in for y1 and positive 3 in for y2. Okay, here's mine. So I would do x divided by, and now anytime you type more than just a simple variable or a simple number into the numerator or the denominator of a fraction, you have to put parentheses around it. So notice I have parentheses around x minus 6 there. And then for y2, I'm going to put 3. And who knows what the last thing was that we graphed, so hit zoom 6 to put us back in a normal window. So what I'm looking for here is where this blue curve, x over x minus 6, is less than or equal to 3. So I notice that it's equal to 3 where they cross, which it looks roughly around 9 right there. But I don't want to know where it's equal to it. Well, I kind of do, but I also want to know where it's less than 3. So that would mean below this red line. Well, for one thing, I can see that this entire curve right here is below the line at y equals 3. So the question is, when does that curve stop and this upper curve start? So look for your asymptote here. We would have, can you see that your line is kind of at 6 right there? So that tells me that part of my answer, going back to my video, part of my answer is for x is less than or equal to 6, because that would give me that entire lower graph here. Now, for this half of my inequality, for x over x minus 6, I'm going to be less than 3 from this point right here where they intersect and forever forward from there, because that will stay below the red line from there on out. So I need to figure out exactly where that point is. So this is where you're going to need to remember some stuff. You press second trace and you go to the calculate menu. You see option number 5 right there for intersect. You want to choose option number 5, and then it's going to ask you a series of questions down here. Now the first question is asking first curve. Now I don't want to be on this curve over here. I'm not trying to figure out where it intersects with the red line. I'm trying to figure out where this top curve does. So I'm going to have to hit the right arrow until I move off of that curve and onto the next one. My blinkers disappeared, so I'm thinking I'm probably coming back here soon. Look at that. Okay, so I finally made it back to that curve. Once your blinker is on this curve over here, and it does not have to be at the same place as mine, but once it's on this curve over here, hit enter. Then for the second curve, as long as it's on the red line at y equals 3, you're good, so hit enter again. And for the guess, you don't have to do anything but hit enter. So that intersection is at x equals 9. So I know that for all x values from 9 forward, x over x minus 6 is less than or equal to 3. So that would be, in inequality terms, x is greater than or equal to 9. So my answers are x is less than or equal to 6, and x is greater than, excuse me, and that should be 4. X is greater than or equal to 9. Come on. Okay. We're going to change that to 4. Okay, so I want you, let's also now go look at the table for that. If I go look at the table now for my functions here, and I want to change my window or my table set. Give me a minute here, sorry. Okay, so I'm looking for when do my y values become less than or equal to 3. So all of these And then notice here where I get the error. That error tells me where my asymptote is. So if I wasn't sure from before if that kind of jump from one curve to the other occurred at 6, I now know that because of that error, that is where it occurs. And then all of my y values are bigger than 3 on 7 and on 8 until I get to 9. So the table can help you to identify the asymptotes, and it can help you to figure out exactly where you equal 3, as long as it's at an integer location. If it was, 9.024 is where our functions intersected, then my table wouldn't really help me to find that. But your table can help us in making sure that where our asymptote really is, because we're looking for that error value. Okay, so I want you to pause the video for a minute, and I want you to give both number 3 and number 4 here a try algebraically. Or not algebraically, excuse me. I want you to use your graphing calculator to give number 3 and number 4 a try. Okay, so this should be the graph that you got for the first one, x over x minus 3 and y equals 4. And we're looking for when x over x minus 3 is greater than or equal to 4. So that would mean above this red line, which doesn't ever occur on this first curve. But when we make our jump to our second function, our second part of the curve, all of this up here would be above 4 up until we get to that intersection point. So you can use your table to verify it, but you have an asymptote here at x equals 3. So, and then the intersection point occurs at x equals 4. So your answer for this would be between 3 and 4. Now notice here, my inequality sign was an or equal to. So I included the or equal to on the 4, but not on the 3. I want you to kind of think about why for a minute. Because at 3, that's where I had my vertical asymptote. And so y doesn't actually exist there. My function x over x minus 3 can't exist if x is 3, because I would get 0 in the denominator. So I can't include it as one of the answers. I can just use it as a boundary. So if it's an asymptote number that you're using, you cannot use an or equal to. Okay? So that actually takes me back to the problem we just did, and I should correct this to be strictly x is less than 6, not or equal to, because of that asymptote. Okay, and then number 4 was really putting you to the test because it was seeing if you were paying attention. On number 4, you had an equal sign. So all you were looking for on number 4 was where this curve for this rational function intersected -2. And if you graph both of those, you will see that they intersect each other. There's -2. There's 8 over x plus 1. They intersect, if you do the second trace intersect, they intersect when x is equal to -5. So your solution is x equals -5. Okay, so now let's talk about solving inequalities algebraically. This is going to take a little bit of paper on your part. It's not necessarily hard, but it's going to require some paper from you. So we have two situations here. If this was just an equation, I would just multiply both sides by x minus 8 and go to work solving the problem. But because of the inequality sign, I have to consider two possibilities. The possibility is that my least common denominator, which is x minus 8, that it's positive. And then my second possibility is that my least common denominator is negative. Because taking that least common denominator then and multiplying it over, if it was negative, what is that going to do to my inequality sign? It's going to flip it over. And so that's going to affect how we solve this. If I'm solving it with it being positive, then that would not change my inequality sign at all. So I would simply take both sides and multiply them by x minus 8. So I would have 6 over x minus 8 times x minus 8 is less than or equal to 3 times x minus 8. And I did not change my inequality because my LCD is positive. So here, that would just cancel out the x minus 8. So I would have 6 is less than or equal to, and then over here I would distribute 3x minus 24, and now I have a basic inequality. So you would add the 24 over and you would get 30, divide by 3, and we would get that x needs to be greater than or equal to 10. And I'm going to flip it around so that it's how we're used to reading it. So that's a situation where x needs to be greater than or equal to 10. Now we also have to consider domain restrictions here. So the domain restriction would be that the least common denominator cannot be 0, because we cannot have it equal 0, right? Because our denominator wouldn't exist. And in this case, we need it to be positive. So we set it greater than 0. So for this one, x needs to be greater than or equal to 10, or x needs to be greater than 8. So which is the most restrictive, to say greater than 8 or to say greater than or equal to 10? So if we combine these two things together, the most restrictive answer is x needs to be greater than or equal to 10. And we'll talk a little bit more about that in just a minute. So if we look at when the LCD is negative, we would work our problem the exact same way, except from the very beginning, we would know that when we were multiplying by this x minus 8, I'm multiplying by a negative value. So that would take my inequality and flip it to a greater than sign. So I would have 6 is greater than or equal to 3x minus 24. 30 is greater than or equal to 3x. 10 is greater than or equal to x. And then if we flip that over, x is less than or equal to 10. But we have to also do our domain restriction here. Once again, we cannot equal 0, but in this case we want it to be negative. So we would say x minus 8 is less than 0, so therefore x is less than 8. So of these two things, the most restricted answer that includes the least amount of numbers is to say that x would need to be less than 8. Okay. Think about it kind of like a number line here. If I go back to this part, if I had a number line and it had 10 and I wanted to be greater than or equal to 10, and it had 8 and I wanted to be greater than 8, well, which of those inequalities includes both pieces of that, or is the most restrictive of it? That would be in limiting it to 10. Same thing here. If I take a number line with the 8 and the 10 on it again, my first answer told me that x needed to be less than or equal to 10. So I would start at 10 and I would go that way. The second inequality told me that x was less than 8. So I would start at 8 and go that way. So the shading that includes both solutions is to use 8. So we say x is less than 8. So both of these are our correct answers. Either x is greater than or equal to 10 or x is less than 8 would make the inequality work. Okay, so I know that's a lot in that problem and you're probably a little bit confused. So if you need to rewind it and go back and watch over it, I strongly suggest doing that. And then I want you to take a minute and pause this and give number 6 a try. Okay, so remember you have your two scenarios. Your LCD is positive or your LCD is negative. If your LCD is positive, you keep the inequality like it is at the beginning of the problem, and you just multiply by that least common denominator, in this case the x minus 2. So my greater than or equal to stayed as greater than or equal to, and then when I multiplied both sides by x minus 2, that left me with 6 is greater than or equal to negative 4x plus 8. Then I subtracted the 8 over. That gave me negative 2 is greater than or equal to negative 4x. Then I divide by a negative 4, which does flip my inequality. And I end up with 1/2 is less than or equal to x, or flip it all around, x is greater than or equal to 1/2. But then I also have to look at, if the LCD is positive, that would mean that x minus 2 is greater than 0, or x is greater than 2. So then when I put both of those situations on my number line, here is x is greater than or equal to 1/2. Here is x is greater than 2. The shading that includes both of those is to start at 2 and move to the right. So that would be x is greater than 2. So that's half your answer. Then you go to what if the LCD is negative? So you would have your inequality, but you would flip your inequality sign from the very beginning. So the greater than or equal to flips to a less than or equal to, and you multiply both sides by your LCD of x minus 2. So that becomes 6 is less than or equal to negative 4x plus 8. Subtract the 8, you get negative 2 is less than or equal to negative 4x. Divide by the negative 4, and in the process you flip your inequality. So you get 1/2 is greater than or equal to x, or x is less than or equal to 1/2. Then the fact that our LCD is negative means that x minus 2 is less than 0, or x is less than 2. So drawing both of those on the number line, the most restrictive answer is to start at 1/2 and shade to the left. So that would be x is less than or equal to 1/2. So your two answers are x is greater than 2, or x is less than or equal to 1/2. Okay, so hopefully that second one started having it make a little bit more sense to you. I want to end it with another word problem here. And I want to see if you can maybe figure this one out based on the puzzle problem that we did at the beginning. So why don't you take a minute, pause it, and see if you can figure it out. Okay, so this problem says a jet travels 3,950 miles from Chicago, Illinois to London, England, and then 3,950 miles on the return trip. The total flying time is 16.5 hours. The return trip takes longer due to winds that generally blow from west to east. If the jet's average speed with no wind is 485 miles per hour, what is the average speed of the wind during the round trip flight, so overall? All right, so the one thing you need to understand is that time is equal to the distance you travel divided by the rate that you travel at. So our total time was 16.5 hours, which was equal to our distance traveled divided by our rate. But our distance is split up into two segments. The distance that we travel to and the rate that we're traveling at, and the distance we travel from and the rate that we're traveling at. So my total time was my first leg traveling to London, which was 3,950 miles, divided by my speed. So you may be wondering where I came up with 485 minus s. Well, on the way there, it's not going to take us longer because we're going to have the wind going with us. So it's going to be pushing us towards our destination. So you would take your average speed of 485 minus s. And then on the return trip from London back to Chicago, it's the same distance, 3,950, but at this point we're going to have to add the wind speed in because it's going to increase the amount of time that it takes us to get there because the wind is going against us. So we would have 485 plus s, and s in both of these stands for the wind speed. And that's going to equal our total amount of time that we're flying, which is 16.5 hours. So this blue piece right here is my rational equation that I have to solve. So my LCD becomes 485 minus s and 485 plus s. So I'll put those out here. When I multiply through by both of those, my first fraction, or rational expression, ends up being multiplied by 485 plus s. My second one gets multiplied by 485 minus s, and then 16.5 gets multiplied by both of them. So you're going to get some really big numbers, and you might have thought as you were going, if you were doing this correctly, oh no, I cannot be doing this right if these numbers are so big, but they really are that big. So distributing all this stuff out on the left, we get these numbers here, and then on the right-hand side, we would have to FOIL this out and then distribute the 16.5 through to get these numbers over here. Combining like terms, we end up with 3,831,500 equals 3,881,212.5 minus 16.5 s squared. Then we would subtract the 3,881,212.5 to get 49,712.5 equals 16.5 s squared. Then you could divide by the 16.5, and look, our numbers are becoming much more normal now. We get 3,012.88 equals s squared. So then when you square root that, you get that your wind speed is 54.9 or 55 miles per hour. which that sounds reasonable. It would not be surprising to hear that, wind speed up in the atmosphere when you're flying in a plane is 55 miles an hour. So, long video today. I hope the solving inequalities and the solving the word problems make sense to you, and we'll do some practice with it.